In this video, I'm going to show and tell you how a closed-loop refrigeration heat pump system works. So here's a little one that I'll be using to demonstrate and stuff on. This came out of a mini refrigerator. So there's three main parts to it. There is the compressor, which is this black can. Then there's the condenser coils, which are the hot coils, and it is the bare copper coils, which I have wrapped around here. And then there is the evaporator coils, which are the side that gets cold. And you can see it's over here, and it's made out of a stamped sheet metal thing. Also, there's some smaller parts, which is like this compression chamber right here, and the orifice, which is a small copper pipe. So basically, what happens is inside here there is a refrigerant, and I'm pretty sure in this one it uses Freon, which is banned nowadays because it does bad things to the atmosphere. But it compresses it down into a liquid which flows through the condenser coils over here, and that's why it's called the condenser coils. And so before it's compressed into here, the gas is, fairly large, takes up a lot of area, and then it has heat in it, and then it's compressed down into a liquid, which is a lot smaller and stuff, and it's all compressed into this little pipe here. And so all that heat which was spread out into it is now concentrated into a small area as it's flowing through this pipe, and so it can easily radiate off of it. And when that heat goes away, then there's a lot less heat in it, and so it comes over here, and this is just a compression chamber so that it has some room to compress a bunch of gas into here stuff. Then this pipe right here, it limits the airflow so that it can actually build up a pressure back here. And this little pipe goes all the way into here, finally up to here, where it can come out to this low pressure area. And when it comes out to the low pressure area, since all that gas, which was squeezed into a very small area, and its heat was taken away, was radiated off in these coils, now once it expands, there's very little heat in it, and so it gets really cold over here, because it's absorbing heat from the air. And if you touch it, it's absorbing heat from your hands and stuff, so it has then sucked up a bunch of heat. And then it makes its way back into the compressor, and it compresses it down again, and so all that heat is back into that small area where then it can radiate out again. Now let's plug it in. You can hear it's pretty quiet. You can hear some liquid sounds coming from it. Turn the microphone, you can hear it. But this is just running off of 120 volts AC. There's a thermal cutoff switch inside there to prevent this thing from overheating. And inside this little can here, it's pretty much a little motor which sits vertically, I'm pretty sure. And then up in the top there'll be a little piston compressor. It's got a very, very small piston, and depending on the size, there'll be there's generally one, but some bigger ones they'll have two. I've seen that in some. But it's filled with oil around it to keep everything cool and lubricated, so nothing will seize up and overheat. And it pumps the oil around through there to keep it all cool and lubricated and stuff. And the tiny compressor, it's quite small, but it can do fairly high pressure, and you don't need a bunch of airflow for this thing, or a bunch of pumping capacity and stuff, so it works perfectly fine for this application and all that, and that's why they're used. And the loudest sound that's coming from here is the refrigerant flowing through this orifice. And so all of this piping is getting warm. It's lukewarm right now. And then already this is getting nice and cold. Peltier thermoelectric units will generate about a 30-degree differential between the hot and cold sides of it, and they're quite inefficient, and that's all they do, and they suck up a lot of power. This thing, it just takes 3.3 amps. The LRA is 3.3. But this thing will produce about a 100-degree differential in temperature between the hot and cold side. The other day when